There we go. Sorry for a little bit
Hooray.
of delay. We had a few things we had to fix. But this will be the, 2023, 2022's last episode. We'll be back in January at some point. But yeah, and this time we have Rags from DataStax here to talk about Cassandra. I'll just give a few updates before. So we have the work on Quarkus 3 is coming, and there was a new release, Quarkus 3 Alpha 2, I think. So if you are using like the core functionality of Quarkus, like the REST endpoints, or sorry, REST EC, or so the core extensions, please try it out and give us feedback. The reason why we're asking and having a longer period of release this time is because we are migrating to Takata namespace. We've done everything we could to make it easy, but in reality, we might miss something. So the more we can get people to try it out, the better we are. Cool. And then we got Holly and Eric. Holly, you say that the sound is bad for you, or is it just me? Am I? Okay, no echo. We'll see. I'm not getting anything.
I've got like an Inception echo, so I need to try and make that stop. Because I'm still about 5 minutes ago on what you were saying, and it's just like spiraling.
Oh, okay. Well, we'll see when I stop talking if it helps. So anyway, if anyone's online, you can ask questions in the chat, and we'll put it in and fit in. And but anyway, Holly, Eric, you've been here before. I'll let Rax introduce himself, and we can get started. So Rax, who are you, and why are you here?
All right. Glad to be here. I know I can't believe it. It's already 2023. And I think early part of 2022, was it in Austin, Eric, that you and I did this in person, right? Where we had a hands-on lab on Quarkus and Cassandra. We have come quite a bit from there. But what I was going to do today was, go back to what Nicholas Wirth said. Basically, programs is equal to algorithms plus data structures, right? So if you think about programs that need to be responsive, you want reactive programs plus data which kind of reacts. And I'm using this overloaded, right? In the same way. So what we are going to have, what we're going to talk today is, rather than focus on the driver itself, and I know that we've been talking about dev services as well for Cassandra on Quarkus, but today I'm going to be using the driver, but not really spend too much time on really talking about the driver itself, and basically build a simple app that I can hopefully build in the next half an hour or so. I have a lot of slides to get through, but the goal here is not to kind of go through all of them exhaustively, but really kind of focus on what you can get done with the driver. Do Eric and Holly want to introduce themselves before I introduce myself, or should I go ahead and introduce myself? Maybe I should, since I already brought up the slide. I am in different avatars in LinkedIn, in GitHub, and Twitter. Raghavan Srinivas, but for whatever reason, people have a tough time pronouncing my name, so I just go by Rags. Rags, not Riches. Easiest way to remember me. I come from the Java side, Cassandra side, Kubernetes side. I'm a developer, architect, but really I'm a software developer at heart. And that's really what I get excited about when I talk about Quarkus and Cassandra is, you will see that today I will be pushing some images, into a registry, standing up that from, essentially on a Kubernetes cluster, and kind of do it all pretty much, kind of focus on the inner loop of container development, which is always fraught with all kinds of issues, right? But using Quarkus, using the zip plugin that we're going to use today, Cassandra makes it a lot easier to develop this simple app, and I can kind of walk through that as we go along. We also do workshops, and I'll point you to that later. We do every Wednesday workshop, and please jump in. And pretty much we're going to use the same infrastructure that we're using today. We're going to use Gitpod, and we use Gitpod for most of our workshops. And the idea is that you can learn from doing. As a mechanical engineer, I know how tough it is to show something in motion in software. But I think the closest you can come to is kind of a hands-on lab or a workshop. With that said, I'm not monitoring the chat, so if you don't mind, if you guys can ping me if there is anything on chat, happy to kind of try to answer that. One of my partners in crime, Alexander Dutra, actually, who wrote the driver, and unfortunately, he has a doctor's appointment that he couldn't, reschedule. So we would be, if you want to jump on our Discord, he'd be happy to answer those questions, but I can also channel it. And with that said, I've been talking a little too much, so maybe I should let Holly and and Eric, sorry, I don't know why I said Andrea. Eric DeAndrea talk and introduce themselves.
It's funny, that happens all the time. Like, especially people will even send an email and call and just say Andrea, and I don't know why. It happens all the time. I guess I'll go first since I spoke up. So I'm Eric DeAndrea. I work for Red Hat. Like Rags had mentioned, we've actually done this workshop before in person. We did it back in May in Austin, Texas. And a little funny story, Rags and I live about 20 minutes from each other, and that's the only time we've ever met in person. We had to travel halfway across the country to meet each other in person. We really need to get lunch or something sometime soon.
Absolutely. Yeah, and now I remember, I did the workshop by myself in January, but you did a whole bunch of significant enhancements that we presented in May, and it was a lot of fun. Yeah, agreed. We've got to do lunch more often.
I used to have that same thing, just even with some of my colleagues, that we'd work together in London, but we'd never see each other. And then we both travel to the US and, have a proper meeting, which didn't seem right, but something about being away from home. So I'm Holly Cummins. I also work for Red Hat. I'm one of the Quarkus software engineers.
And I'm Max, also work for Red Hat, and I know very little about Cassandra, so I'm looking forward to this. So I'll let you get started, Rex.
Absolutely, yeah, Max. Again, thanks for having me, and thanks everyone for joining. So I have a few slides on what is NoSQL, what is Cassandra, and then talk about Quarkus. But really, I'm calling it the microservices nirvana, which is kind of putting reactive program responsive data, and then do some live coding, and then follow it up with resources. Eric, I know we made a submission for DevNexus, right? I don't know where we are presenting this workshop in person, if you want to see us in person, but hopefully some part of the world sometime, right? Pretty soon, hopefully. So what we're going to do today is build a simple to-do app, and we're going to leverage the Cassandra driver, the Cassandra extension, which sits on top of the Cassandra driver. So you will see the object mapper in action. And Eric would be happy to, I know he would be happy to talk about how to use the uni objects and the multi objects, and I'll walk through the source code a little bit, and then we'll kind of go from there. But what the heck is NoSQL, right? Actually, it's kind of crazy. This term caught on because somebody needed a catchy hashtag, right? Because you want as many eyes on a particular tweet or whatever, right? And for some reason, NoSQL caught on. So sometimes it's also referred to as not only SQL, but the idea is that people were a little bit tired of Oracle, okay, for a variety of reasons. And from a development perspective, if you think about like the Oracle database as it existed, in 2009, which was around the time NoSQL kind of started getting some traction, you can only scale vertically, right? After a while, it essentially is going to keel over and fall, right? Because you can only go vertically so far. But in in general, the NoSQL is really all about kind of distributing your data across commodity hardware. I remember, and I'm going to give out my age here, but essentially, I started with a 20 megabyte disk with a PC XT, and it was ridiculously expensive, right? Now I was out, really on the moon when I got upgraded from my XT to my AT, which was 20 megabytes to 40 megabytes, 40 megabytes of disk data. Imagine this, right? But really, disks have become so cheap that it's okay to distribute your data and have multiple copies of this so that you are resilient in terms of distributed systems. Because one of the things with distributed systems is that you're going to fail at some point of time or another, right? And remember, again, not only SQL or NoSQL was there even before the cloud, but in general, when you want to kind of compare relational versus NoSQL, it's really about this vertical scaling that I was talking about just now versus horizontal scaling, right? But we all know that, what do you do? There is always a downside, right? Or there is always some kind of limitations for something, because there is really no silver bullet. Otherwise, even Oracle would have gone, completely NoSQL, right? Many of the NoSQL databases today, don't support strong consistency, or what is referred to as ACID. ACID stands for atomicity, consistency, isolation, and durability, right? But again, there is a lot of things which are blurring, and I'll talk about that in a second. And even Cassandra actually is adding ACID transactions in 2023. And I'll talk about this briefly. We have a summit coming up in San Jose in 2023 March. And I know that, Red Hat, thank you very much. You also submitted to the Cassandra Summit. The CFP just closed last night, but I have a feeling that you may still be able to, submit next couple of days. Don't quote me on that. But again, going back to relational versus NoSQL, it's really about horizontal scaling versus vertical scaling. But what are the downsides, right? There is always a catch. We know that. The catch is that you're bound by what is referred to as the Brewer's conjecture or the CAP theorem. You might have heard of this, but if you want to think about distributed systems, there are a bunch of different characteristics. But if you think of the three primary characteristics, right? Consistency, availability, and partition tolerance, right? What do they mean? They pretty much mean what you think they mean, right? Consistency is like, the last write should be the one I read next, okay? And many of these NoSQL systems have to pick only two, or that's the, the Brewer's theorem, or the Brewer's conjecture, or the CAP theorem says. So it's all fine when there is no failure, right? You can have consistency, you can have availability, you can have partition tolerance as well. But when it comes to a failure scenario, you have to lose, or you have to sacrifice one of these, right? You have to sacrifice either consistency or availability or partition tolerance. Turns out nobody wants to sacrifice partition tolerance, because your data becomes in such an inconsistent state that, even my grandmother, can figure out that the data is inconsistent, right? But if you're not on top of the leaderboard for 15 seconds, it's probably not a big deal. Maybe it is, for some of you who are gamers, right? If it's not available for a few milliseconds, it's probably okay. So that's something that you probably, you have to make. You basically have to decide, what would you like to give up? Either it's consistency or availability. And again, when there is no failure scenario, you can have strong consistency, you can have it always available, and it is able to tolerate partition tolerance because there is no failure anyway, right? But the moment you have a failure, you have to pick two of the three. Like I said, NoSQL systems don't give up partition tolerance because that's a bad idea. It's okay to give up consistency. It's okay to give up availability. But again, you can tune the degree of consistency for many of the NoSQL systems, including Cassandra. So if you look at the ecosystem of NoSQL, and there are like, hundreds and hundreds of them out there, right? But Cassandra is probably the most popular of these systems. Of course, Mongo is there as well, and there are a bunch of others as well which are quite popular. But depending on the use case, I think and I was at AWS reInvent just last week or 2 weeks back, and a lot of customers came up to me and said, in fact, the NoSQL system that I'm using, I haven't really touched it in years. Hopefully they're upgrading it and all that. But the point is, and you will see that Cassandra is great when it comes to availability and also scalability. All right, what is special about Cassandra? It's really no single point of failure. There is really nothing like a master. There is a coordinator, if you will, and that you may call it the master for that particular write or read. But there is really no single master. So for some reason, if you lose contact with the master, some of the NoSQL systems you really are host. Even though you may have your data on other nodes as copies, right? But with Cassandra, essentially the drivers are intelligent enough in the drivers itself kind of have a similar architecture as like Kubernetes, where you can essentially load balance, you can distribute your loads and so on. But essentially what it does is it really scales for reads and writes, and really application can contact any node, which is very critical. Might seem like a small thing, but it's very important. How do I have a simplistic view of what Cassandra or a NoSQL database is. Basically what it is it's it's like a distributed hash table, if you will, right? I can write a distributed hash table myself. What's the big deal, right? All that I need is basically I can take the key and I can hash it to a particular partition. I'm pretty good at hashing. I can figure out how many number of nodes, and I can distribute it across those different nodes. But the problem arises, what happens in a distributed system is its dynamic nature, right? So nodes come in, nodes go out. Now, all of a sudden, your hashing algorithm may not adapt, to those changes. So the way I think about this is, Cassandra and NoSQL systems, they take care of all of that for me, kind of distributing the data, keeping appropriate copies, going to the right node so that you have order of one access, right? So it's a constant time access, milliseconds or whatever, because the hashing algorithm uses something called as a consistent hash algorithm and makes it very easy to access the data both for read and write. I already alluded to that. You can make Cassandra not available for a certain time if you make it strongly consistent. Okay, so maybe it's okay in certain use cases. Certain scenarios is probably okay. And like I said again, we are coming up with something that is going to be an API for ACID, where you can demarcate a transaction by like a start transaction and an end transaction, and everything within that boundary is either going to be done fully or nothing, right? I mean, that's really what a transaction means, or that's what strongly consistent.
So do I have it right that Cassandra, like the main difference from Cassandra to other NoSQL is that it's like there's no central coordination?
I wouldn't say so. There are other NoSQL systems also, but I'm glad I didn't pay you to ask the question because it's perfect. Really, here's where I think Cassandra distinguishes, and we have heard this over and over again. And these are all public studies that are out there that you can kind of take a look at it yourself. What distinguishes Cassandra is the linear scalability part, right? It's very easy, to kind of scale, initially, but what happens is at some point, it kind of levels off, right? It kind of goes up. Let's say you double your nodes, you double the performance, 4 times 4, 8 times 8. But at 16, it may start going up to 15 or something like that, right? My apologies. And what I think is the biggest distinguishing factor in terms of Cassandra, and I've heard this over and over again, because it's not just DataStax who's working on on Cassandra. As many of you know, this originated at Facebook. Facebook, I don't think uses it anymore, or Meta or whatever. But Apple does use it. So if you're using the Apple iStore, chances are your data is going into some Cassandra cluster somewhere. In fact, Apple talked with us at the Cassandra Day, which happened simultaneously at Bellevue, Houston, and Santa Clara, and they talked about kind of this linear scalability part. Okay. So I don't know if that answered your question, Max. The primary distinguishing factor, I think, is the scalability part. And like I said before, it's pretty straightforward to do this to a certain degree, but you need to have an algorithm. You need to have a paradigm, in such a way that it linearly scales, and that's probably the biggest distinguishing factor.
I think too, Jags, if I don't mind me jumping in, the whole ACID transaction thing is a huge thing, because now if you think about, you've got it kind of goes right with the slide that you're talking about. You've got all these different clusters all over the world, and being able to have an ACID transaction that guarantees commits across all your clusters in the world is huge. And I think that a lot of that was contributed by Apple as well, wasn't it?
Absolutely. Yeah. Apple contributed quite a bit for that, and there's still a lot of work to be done. In the sense that I still don't know how the drivers are going to evolve, to support this, because as a software developer, it's not that I don't care, but really what I want is a simple API to be able to use that, right? I myself have actually, and I'll talk about this in a second. I have a Cassandra cluster which is distributed across Google Cloud, which is GKE, and EKS, which is the Amazon Cloud, right? And I've installed this via Azure, which is AKS, which is kind of mind-boggling. But the reason it happens, or the reason why I could do that, is because Cassandra uses something called as a gossip protocol, which is a little bit chatty, but not excessively chatty. So it has information about its neighboring nodes. So if it wants to reroute the traffic and all that, there is some level of intelligence, but not too much in there, right? So because of the gossip protocol, once I enabled the networking, it was very easy for the Cassandra nodes to talk to each other. So it goes back to what you were saying, Eric. I'm kind of very curious to see if I can complete an ACID transaction on my Cassandra cluster, which spans GKE and EKS, and maybe at some point I'll add AKS as well. Right now I'm just using it to install, but it's really cool to be able to do all that. But again, if you want to think about this, the reason this happens is because Cassandra was there even before the cloud, right? Before the cloud became popular, and was based on some simple protocols. Now, one other thing that we have, and we're going to be using it today in our coding session, is AstroDB, which is database as a server. It's serverless, scalable. It's multi-cloud. Multi-cloud meaning you can have it either on AWS or Google or Azure. Okay. I don't believe there is an easy way to combine those. And if you want to be able to do that, then of course you have to use Kubernetes, and I'll talk about that in a second. It's NoSQL, multi-model, tabular, document key value. Key value is probably where I think, again, you can get order of one access, constant access, and it's based on the open source version of Apache Cassandra. Okay.
Guys, got a quick question. Oh, here we go. Never mind that. You led right into my question. Where does Stargate play in all this?
Absolutely, yeah. And many of you might know that one of my colleagues, Raghavan did and I'll point you to that as well. We have, but let me kind of back up here. What Stargate is a unified API to be able to use, Cassandra, okay, on the cloud, or really anywhere, okay? Because what we do is we front end our Cassandra data with Stargate, and what you can do with Stargate is you can use any of these different APIs that are here, which is really, really cool from a developer perspective, right? I can use SQL, which is pretty popular, and I think that's what we're going to be using today. Then you can do JSON, of course, and GraphQL. REST endpoints, or you can do gRPC, which is really how most of the microservices operate anyway, right? So essentially, what Astra does is it has a Stargate API, and in fact, you can get $25 per month credit, which is pretty much for the rest of your life. I'm thinking, but you never know, right? But you don't even have to put your credit card. And for most of our workshops, this is the first thing we're going to do. We're going to get an Astra account, and many of you might already have it, and you can use it. You create a key space, and then you're good to go. Okay, and we're going to create a key space today, programmatically anyway. Okay, did I answer your question, Eric?
Yeah, and I think Stargate, you guys actually is implemented in Quarkus, right?
Correct. That's what I was going to say, and glad you came up. You brought that up, but I have a pointer to another Quarkus insights that my colleague Ivan Senik, actually was a guest there, and you can look at why. We kind of looked at all these different Java native platforms, including Micronaut, Teledon. I'm not quite sure all of the different platforms, but we did look at quite a few of those, and then eventually decided to go with Quarkus, which is pretty cool. So I'll point you at that as well, or Eric, maybe you can put it in the chat, and if anybody's interested, they can take a look at that as well.
I owe you a blog post about that too. I know I owe Peter a blog post on Quarkus.io about it.
Absolutely, yeah. So bunch of information in there, and will be great, because I know that I'm talking to a lot of developers who are kind of evaluating these different native platforms, and today, given time, we will actually develop the to-do app, or at least compile it to run native, but take a look at it, especially if you are evaluating the different platforms, especially if you want, you're interested in native response, to your programs. But one of the cool things that we can do with Cassandra is that we have a project, open source project called Cassandra, which I like the name.
I was just going to say that needed to be written, if only because the name was just waiting to be implemented. It's so perfect.
Exactly. Yeah. So I thought it was really cool. And basically it's Cassandra running in Kubernetes. I think, I personally, I'm really fascinated by this project, although many of you might think, I don't want to manage this, I don't want to worry about Kubernetes and all that, and use Astra. But if you want to do, a self-managed, but not really have to do everything yourself, Cassandra is a great alternative. One of the biggest criticisms, which is very relevant, is that Cassandra is hard to manage. With Cassandra, it's kind of somewhere in between. You could really put it on any cloud, or you can put it on-prem, as long as you have it with Kubernetes running. And if you have the and this, especially if you have resources or kind of the manpower to be able to do Kubernetes, Cassandra is a great alternative. We're not going to touch on Cassandra today, but what it does is it implements operators and essentially does most of the day 2 operations for you, like backup restore, right? Despite what you have in terms of resilience and all that, you do need a backup and restore. So we have Medusa, which is based, it uses Minio, S3, makes it a lot easier to be able to back up your data and all that. You install all of this using Helm. We used to install a CAS operator, which takes care of all of this, but lately we have updated it with the Cassandra operator. And essentially, if you want to think about this hierarchy of operators, the Cassandra operator kind of takes care of the multi-cluster, multi-cloud, multi-region install. And once you dive into that particular cluster, the CAS operator takes care of these day 2 operations, which is like providing the Stargate API, right? That's how you're going to use this, right? Or being able to repair, or being able to get your metrics, using Grafana, Prometheus, and so on. Okay. We also, you can really use it with any ingress. This is after all Kubernetes, right? But make it easier with Traffic. But I think I've used Nginx as well in some of my Cassandra clusters. I have pretty much Cassandra cluster, installed on my laptop, pretty much all the clouds, combination of clouds. So, you can do, pretty much whatever you want. Okay, I've spent too much time on this, but one of the reasons I love Quarkus is because of the inner loop, right? And I myself, when I do containers, usually, I'm Dockerizing it, and I push it to the registry. From the registry, I need to stand it up. All of this done in one step, and you'll see this, and you'll kind of appreciate how easy it is to do this. And somewhere in there, I may also want to kind of debug the application, right? So all of this can be done, and I know I've not even touched the biggest advantage of Quarkus, right, which is testing, right? Obviously, in today's code, it's not really production code. It's something that I wrote as kind of a proof of concept, right? But I know that Eric would be happy to talk the remaining 8 hours, right, about testing. So I think testing is very critical for developer productivity as well, right? And I think Quarkus makes it a lot easier. I don't know if I'm it's my bias, but definitely I'm completely sold on this inner loop, and making significant changes to the inner loop, or making significant productivity gains in the inner loop will definitely make it more productive from a developer perspective. We know that it's still Java, and we all know this, how Quarkus. So I'm not even going to spend too much time on this. But the idea is that if you can take a penalty at compile time, which is fine, but your runtime should be faster, right? Again, I'm giving away my age if I can say that I used Corba and all that. Some of you might actually get some nightmares, when I mention that. But the idea is that distributed systems have evolved. It's kind of a continual evolution. And today, if you want to think about it, it's really about microservices. And even if you are a traditional monolith, I think it makes more sense to kind of do it as a microservice, just given the very nature of how software development is evolving. I think if you just look at the guests today, we are all distributed around the world, and you need to be able to form groups so that you are focused on a particular aspect of the entire solution, and that's really how microservices works. So that you can independently CI/CD this, and there are a lot of different advantages for doing this, and Quarkus makes it a lot easier, and obviously containers also makes it a lot easier. And again, NoSQL has a good synergy with programs, with Quarkus, with some of these microservices artifacts, if you will, because again, you can scale data independently of the program. This is the
the diagram that keeps giving.
Yeah, I mean, everybody has seen this, and it's pretty scary, right? So the goal is, really, there is no way you can kind of cover the entire landscape. To be able to pick and choose, some of these components, right? I need a database, obviously. I need something for streaming and messaging. You can use Kafka. We have something called as Pulsar. Okay, you can use your own favorite editor and still be able to do this. And today we'll show visual code in action and so on. Okay. Martin Fowler, talked about this principles of microservices, but all of these are very important. And I think it's not just Quarkus that makes it happen, or it's not just containers that makes this happen, or it's not just Cassandra that makes it happen. It's kind of a combination of all of this, right? Highly observable. You need to be able to isolate failure. You definitely need to be able to deploy it independently, right? All of these are important. You need to have a culture of automation, right? And today, if you use Cassandra, for instance, right? I'm using Argo CD and Flux CD and all that. Makes it a lot easier to be able to, essentially do CI/CD around Kubernetes. And really, Kubernetes has kind of become the de facto standard for deployment today, right? But let's go back to the Quarkus Cassandra extension. Basically, like I said, it depends on the Cassandra driver for session support, for object mapper, and support for mutiny types. It has native image support as well. And like I said, if you are patient enough to wait till the very end, hopefully I'll show that in action. And then, you have support for DataStax Astra. But obviously, since this is out in the cloud, you want it to be secure, right? So we use something called a secure connection bundle. I have already downloaded the bundle and started using it. But you can do it yourself. Once you create an Astra account, you can create this and pretty straightforward to use this as well. And I'm sure, Eric, you can vouch for this. Essentially, you point it to the secure connection bundle and then point to the username and password or the client ID in the secret, and you should be good to go. And then you can start using Quarkus Cassandra extension. So like I said, basically there are a number of ways of doing this. If you put it in the cloud, you have to point it to the secure connection bundle, and then what is the key space, and then maybe what's the username and password, and we'll see all of that today. And there are a bunch of things that you can do with enabling some of the Cassandra specific stuff, right? and for example, request timeout, consistency level. Like I said, you can tune that and so on. So all of those are possible as well. We start by injecting a Quarkus SQL session, and then I'll point you at some of the the resources for you to get started. But essentially, you'll create a data access object, and you'll see that I can do many of these mutiny objects by using the Cassandra extension. Okay, so let's see. There is support for mutiny types. I'm sure Eric can talk a little bit more about that. But essentially, what we can do is we can kind of implement it as a REST service. And I know we did this in one of our microservices bootcamp, which actually is coming up in January. And please come back if you want to get a little bit more information on this. Essentially, we deploy this as a REST service, and there is, believe it or not, a complete ecosystem of to-do where you can use a front end in whatever language you want and call this REST service and be able to use the REST service, which is pretty awesome, if you want to think about that. Okay. With that said, let me ask Eric if he wants to talk a little bit while I spin up my cluster. Okay.
Yeah, so the sample application that you've got here, I think we built it in a way that so like some people want to follow like the raw, and we say SQL, meaning like C, the letter C, QL. Actually, I should probably do this. How do I do this backwards so that it's in the right way? Because it's flipping my video. But anyway, if you want to write raw queries, we'll call them queries, you can do it that way. Or if you want to see how the mappers work, and the mappers are similar to like JPA. So if you know how JPA works, where like you define a POJO that kind of mirrors what your table structures would be, you can do the same thing. And the application does it both ways. And it actually uses a build time switch that you can just set a property and will flip between them. And of course, everything is, if I wrote it, it's got lots of tests. So it actually tests both of them as part of the test suite. So it's kind of cool. But for me, when I built it, it was learning how to do it. Like I'd never played with it before. So it's pretty cool.
Yeah, maybe we can talk a little bit about this, right? Application properties. Eric, again, feel free to jump in anytime. But essentially what I'm doing here is I'm using the Secure Connect bundle, right? And then, of course, I provide the username and password, right? And I use this. I don't know if I set this up. Yeah, I think I did. But if I did not, I will. And essentially, what I do here is I set some of these properties, and I'm good to go with respect to Astra. Okay. So I have the username and the password, and that's pretty much it, right? Okay. So let me show you what I'm doing here. Okay. So git remote -v, right? And this is the Git repository. Okay. Let me grab this. I'm sure I have it somewhere here, but so this has fairly lengthy instructions about how you can actually, let me go to the workshop. Okay, so and I'm going to put repositories and find my Quarkus repositories, and these are the two that we're going to be using in today's live coding. Okay, so this is the intro to Quarkus and Cassandra. Okay, and you can see basically I'm using Quarkus Cassandra, and what I'm going to do is I'm going to jump straight to this part because I've already created my AstroDB instance. If you want to do it yourself, it's pretty self-explanatory. Everything is in there. You create an Astro token, and essentially what you do is you're going to use the security bundle, and then you're going to launch this Git part, which is really the coolest part, right? It's basically Visual Studio in the cloud, and essentially what it does is it has like a Explorer window, right? Here's the Explorer window, and here's my editor window, and here's my terminal window, right? And it you can have different bash or shell scripts, shell terminals as well. And this is where I issue my command, right? So for example, let's look at again, this is the connect bundle that I'm using to be able to access the Astra in the cloud. Okay. So let's not worry too much about how to set that all up, because I've done it. But I'll jump straight to my containers part because it's probably the most interesting, and that's kind of what I think there is the biggest advantage, of using Quarkus and Cassandra together. Okay. So there's this whole thing talks about how you can kind of look at your Swagger API. As you may expect, you can get it to do, you can post it to do, you can do a whole bunch of that, but all of that I'm going to skip through. Okay. You're welcome to try it yourself. You can package it as a jar file. We all know that, and we can run that as well. But let's get to the containerization part, because that's probably what I want to spend most of my time here, right? What we start by installing this zip plugin, right? So to be able to do this zip plugin, the zip container extension, essentially what I need to do is to be able to put the secure connection bundle, right? So what I do is I copy the secure connect bundle to a space where zip essentially puts it on the different containers. So all of that happens pretty much automatically, right? I create a I Dockerize. So essentially this is running locally. I can run it locally, but I'm going to skip all that, and I'm going to show you how I can do this with Docker and so on. Okay, so let me try this. Okay, so I'm going to log in, and meantime, Eric, any questions on chat? Unfortunately, I'm not looking at that.
No chat. I guess I have a question. So this, and I've probably asked you this before, and I completely in one ear out the other. But the Secure Connect bundle thing, is that specific to a particular like Astra database or a particular region or a particular environment?
That's a great question, actually. The Secure Connect bundle is actually relevant to the region. So in other words, if I have GKE on Monk's Corner or something, right, it's specific to Monk's Corner. So effectively what you can do is you can use it for any database on that particular region. But typically what I would do is, if I have two different databases, maybe on the same region, I still go ahead and create a new Secure Connect bundle just for that database. But good question there. Did I answer
How would
that?
that work in like native image though? Like when you have to build a native image at build time, would I need to build new container images for if I wanted to move my app from like test to prod?
Native image. You would still, what you would do is you would put it. That's a good question. So here, what I've done in my native image is I'm running it in Jib. But what I'm running it in Gitpod. Sorry. What you are asking is how would I run it? In general, right? With and still use the same master database. Correct? Is that?
Oh, yeah. So if I deployed my app like in test environment,
yeah. So I would.
use one
In other words, if I take the native image and having to containerize that or something, then the native image needs access to the Secure Connect bundle, and you will need to do that. Let me maybe try to generate the native image, and then we can kind of go from there. Okay.
And before you do that, we've got a few more questions that have come in as well.
Okay.
So we've got one, does the extension also work with plain Cassandra without an Astra account, even if the experience is better when using Astra?
Yes. And I did show you the Secure Connect bundle, right? You won't be using the Secure Connect bundle in that case, right? I've myself tried it with Cassandra. I've tried it with Cassandra. So yes, you can do that.
And I think
obviously.
Oh, sorry, that brings us neatly to the next question, which is on the subject of the secure bundle. Does it mean secure connections are only possible using the Astra service, but not with Cassandra itself?
Correct.
And I think
yes, yeah. Yes, that's the implication. I'm just trying to think if there is any way possible. I mean, you could do, I guess, a SQL proxy and then connect to, but then. There may be a way, but that's a good question. So the question is like, can I do a secure connection to Cassandra? Even though Cassandra is not being serviced by Astra, correct? Is that kind of the question?
I think so.
Yeah. Okay. Yeah, it's doable, I think, but I'll have to think about that a little bit. Okay, so let's start by building. Okay, I've logged in, and basically I'm skipping all the tests. Okay, and hopefully, let me make sure I have my Docker login ID enabled. Give me a second. So let me make sure I have my Docker login. Okay, so that will be used as Rax. This is my Docker repo, and now I'm gonna stand it up. Okay, let me make sure that I have a Kubernetes cluster that I'm already using. Okay, so to make sure that I'm using it, sometimes it goes to sleep, so I just want to make sure that I'm doing it right. So I've downloaded the OKTito file, and I've dragged it and dropped it. So let me see if this works.
I think too, Rugs, while you're doing that, when we built this, I think we built it in a way that it has both reactive and blocking kind of mixed.
Oh yeah, that's right. Good point.
Yeah. Like some endpoints are blocking, some are reactive, and why we chose one endpoint over another was, I don't know, I think just out of sheer coincidence or what.
Just random, right? And if you dig into,
just to show that you could do it.
Yeah. What would be the right? Maybe one of the rest.
Yeah. So if you look at the REST endpoints, some of them are blocking, some of them are reactive.
So I can see here, you're using multi and uni. So we just randomly kind of, or I should say, Eric did this, and use multi in some cases and uni in some cases, right? So kind of gives, you can mix and match them, and kind of gives you a flavor of how you can use this as well. But most exciting is being able to push this without really having to do a whole lot, right? I've already set up the secrets, right? And let me make sure that I have the secrets up and running. Okay. Okay. I haven't set it up, so let me do that. That's a little scary. I don't know why it's not working. Get secret. Okay. So let me do that again. And make sure that I have it running. Password and client ID. Right. So I'm going to grab this. And there's the client secret. Grab it here. And the username is something that I will need to add as well. Let's see if this, hopefully I got everything right here. Go back here, grab the username. Is right here. And should work. Okay, so now I should see the secret. Okay, so I have the username and password, and all that I need to do, it's very underwhelming when you do this, is you can push the image. What I'm doing here is I'm building essentially I'm building the container, right, and I'm pushing it all in one step. Okay, so essentially I'm going to do that here, and I'll talk about that in a second. So and again, Eric, feel free to talk about this as well. Basically, what I'm doing is I'm building the image, pushing it, and I'm using this particular Docker login to be able to do that. And the Quarkus Kubernetes deploy is equal to true is going to actually stand it up on my Kubernetes cluster. So all that I need to do is just this one step. And like I said, it might seem a little underwhelming, but that's the whole beauty of kind of using this and simplifying the inner loop, right? Let me show this.
Yeah, and while that's going, for anybody who's interested in learning how to actually use the Cassandra extension, like I said, it implements both the mappers and the raw SQL, and it does it by a build time flag. So there's actually two different classes in there, one that uses the SQL session, one that uses the mappers. So anybody who wants to go peek through the source code and look at one way versus the other way. I hate writing raw queries, so I always go the mapper route.
Absolutely, yeah. Well, and again, you can take a look at the mapper, and look through this, and again, map to do item, which is pretty straightforward, and then you can, like what Eric said, it does offer different options. So even though this is like a fairly simple to do app, right? it does some fairly sophisticated things. So let's see if this is up and running, and you saw that it's okay. Service Cassandra, it doesn't have an external IP, which is not a good sign, right? No, which is fine, right? And it's ready. Okay. All right. So let's see what happens here. Let me go back to my instructions. Okay. So it is, it should basically be running, which is, so maybe it's missing a secret, or no, I'm missing here. I think it's running. Oh, it is. Okay. Miss this part. Okay. So it is running, and what I need to do is just set up a port forward to that particular port, right? So I port forward to service Quarkus Cassandra, which is running, and I'm running it in port 8080. Okay. So I'm going to set up the port forward like what typically you do in Kubernetes, right? And you will see here, service is available on port 8080. Okay. And I'm going to open this in the browser. Okay, and my ask to do is there. Okay, done with containers.
Yay.
Pretty straightforward. And about to try native image. Fingers crossed. But again, if I were not to use this particular command that I used before, right, I would have had to essentially dockerize the image, then push it to the registry, Docker registry, and then stand it up. All of those are independent steps. And I know when I do it myself over and over again, right, I try to take some shortcuts and I miss something or the other. Whereas, again, with Quarkus, it makes it a lot easier. I didn't show you adding the Jib plugin, the Jib extension, but love to use the Jib, extension because it makes it a lot easier. Okay. So let me do the last step because this takes a little bit. And in the meantime, I'm going to finish up the presentation. Okay. Let me go in here and see if it works. Okay. And maybe what I can show is, I don't know why. I was going to palm. Yeah. And essentially here, somewhere here, I'm using the extension. There's a Jib one. So I think this adds the Jib extension, correct? The Quarkus Kubernetes. This by default is not available, but if there is a way to add this. This is the Quarkus container image Jib. Okay, so it has a whole bunch of other dependencies, but adding Jib makes it a lot easier because what you can do, like I said before, is you can package up the Secure Connect bundle as well, so that you are able to connect to Astra. And of course, I have not shown a lot of things where I may want to actually initially deploy it on my local container, right, or my local Kubernetes cluster, which could be Kind, which could be Docker, or any of those, right? Or I can do it on my Cassandra cluster. All of those, I probably don't need to use the Secure Connect bundle, or I don't need to use the Secure Connect bundle, right? And then what I can do is I can, once I'm done this a few times, I can set my profiles in such a way that it deploys to production. And that's something that Quarkus provides anyway. Okay. Anything else, Eric, you want to talk about before I jump back into the slides and then finally show if this is working or not?
I don't think so. I think the only thing we need to add, and maybe it's on me to do, is to put some automation in the repo, like Dependabot and GitHub Actions and whatnot.
Yeah, that'd be cool to do, right? So let's let's keep that a to-do item.
Add a to-do for that. Put a pin in that.
Exactly. Yeah. All right. But you would be surprised, a simple application like that actually gives you a lot of insight into Quarkus and how you can use Cassandra. Pretty straightforward to get started with this, and I'll point you to all the resources in just a second. All right. With this said, let me finish up the presentation. So if we finish the live coding part, and like I said, you can leverage. This is kind of the partition key where you have the user ID, item ID, but it depends on what exactly you want to do. Partition key could be user ID, list ID, and then what you can do within a use. There is a cluster key within Cassandra which makes it easy to be able to list the to-dos for a user, because more than likely you are going to go through all the to-dos, right? So what happens is you hit a cluster, and from that point onwards, all the keys which are using the cluster key are going to be part of this find to-dos or whatever, right? So essentially what it does is it hashes based on the user ID and then picks up all the to-do items for that particular user ID, and that's how you get the constant access, even though you may be looking at multiple items. Okay. Like I said, there is an entire ecosystem around to-do. There's a to-do backend which validates specs and all that. And I'm just going to leave it here. I'm not going to go through that. But this is kind of what we built. We had a front end. We had a back end, essentially with Quarkus, right? And the database was on AstroDB. Okay. That said, resources, attend our live sessions. We also have Menti, which is kind of a lot of fun, where we quiz you. We also, assign you homework and we grade them actually. And then you get a badge, which is kind of cool. But there are a whole bunch of resources. We have actually coming up, there used to be Katacoda, but Katacoda has been sunsetted. But we are building our own kind of Katacoda version on GitHub called Katapod. And you should be able to see that, pretty soon. But, you can go to GitHub. We have a number of videos, and, if you go to youtube.com/datastacksdevs, all of these are, all of the workshops are recorded. I'll just go to datastacks.com/workshops. I believe this week, we have a Netflix clone workshop, which is kind of cool. Again, based on Cassandra. As you can see, we have an entire workshop building a to-do app, right? So a lot of things, but for some reason, a lot of people like our badges. They are able to put it on LinkedIn and boast about it. So feel free to sign up for workshops and get our badge. I'm not sure when we are offering the Quarkus plus Cassandra workshop, but hopefully soon, and hopefully soon in person as well. To be able to try out Cassandra plus Quarkus, including getting more information on the Cassandra Quarkus extension, you can take a look at this particular URL, and basically it's a quick start guide, if you will, for Cassandra. I didn't try it recently, but if you have any issues, please jump on Discord and let us know. Quarkus Insights, I'm sure, has a whole bunch of these different videos. If you're interested in Cassandra, try out Cassandra, but what we saw today was Astra, right? There is a whole bunch of Cassandra workshops out there. If you Quarkus plus Cassandra workshop, actually, again, if you go to just go to github.com/datastacksdevs, you should be able to see that, or youtube.com/datastacksdevs. We have a Cassandra summit coming, and thank you, Red Hat, for submitting a CFP as well. Unfortunately, like I said, the deadline was 11:59 p.m. Pacific on December 11th. That was yesterday. But don't hold this. It may still be available if you try it out. Okay. Any of you made submissions, Eric?
I think Peter Humphrey did a submission, but I think John Klingen or somebody is going to do the spot. I unfortunately can't travel that week, okay. But I think we're going to do a Red Hat Summit submission as well in May.
Fantastic! Yeah. Happy to discuss that. Maybe we should have lunch sometime this week and discuss that. Okay. All right.
So what I learned: Apache Cassandra for ultimate scaling, good integration with Quarkus, and you can get homework.
Yes.
And a badge. Don't forget about the badge.
And a badge, yes.
You can put it on your chest, so you can print it out, and you can wear it around with you.
Yeah.
Awesome. Yeah.
Yeah.
Okay.
And who knows, if you work with Eric, you can even get this nice jacket, right? So, in fact, we gave out jackets for our first workshop, did we?
Yeah, we gave it to the people who submitted the workshops.
Yeah, Eric claims that he sent me a jacket.
I have the receipt that it was delivered to your house. What you did with it from there, not my
fault.
All right.
Anyway.
So Quarkus and Cassandra, let me see if my native image worked. That's the last thing I'm going to check.
I think, Rags, we submitted to DevNexus in Atlanta in April as well. So hopefully we'll come into there. Hopefully we get selected to do this workshop.
Yeah. And all that I need to do is run the jar file, right? So run the runner. And hopefully we're going to get back to the same. Oh, because that port is taken, right? So
yeah, it's just up to dev mode thing.
Right.
Yeah.
I could try a different port. I should have, but in any case, okay.
The good news is it's fast to retry it with native.
Right, but if you want to change the port, you got to rebuild a native image.
Yeah, right, exactly. So
You've got the port forward port open. You've got to close the port forward.
Oh, gotcha. Okay, thank you. See, you got to go through all the steps, right? That's all you need to do. So, not here. But I did have all the steps. So all that I need to do is delete this, and this will delete the port forward as well. All right. Let's make sure that this. Oh, it's still running.
Yeah, so just do a. There you
go. Okay. And trying once more. Let's see. And hopefully this should bring up the to-do app. Yeah. Okay, and again, opening it in browser. There you go.
Woohoo!
Awesome.
So this is the native image with everything set up, right? With that said, let's end with a good note. I know I've gone beyond a little bit, but my apologies for that. But I really want to thank everybody. Max, Holly. Hopefully, I'll have a choice. I'll have a chance to kind of work with you guys, see you in person as well. Hopefully Eric sooner, and everybody in the world, wherever you are, feel free to. My next in-person session is going to be at in Ohio, in Sandusky. I don't know, Eric, if you're going to be there at Code Bash, but happy to see you in person, and Happy New Year, happy holidays, and thanks for having me.
Same to you. Thank you. And we'll end on a note. And time to go. See you around.